For our second example, we have a set of statistics test scores for a class of 40 students and want to group them into classes that are meaningful for the data so as to be able to make a distribution. Where in this case, we should understand here that letter grades are often grouped in terms of tens. That is 90 to 99, 80 to 89, 70 to 79, and so on down till we get to Fs, which are, well, their own thing. Point here is that if we want to break this data set down, the most logical way to do so would be in terms of the natural pattern in the data. That is, our classes would be 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99, with the according frequencies checking through the data set as we go, 3, 6, 6, 11, 9, and 5, respectively, for a total of 40. Where in our first class there, 40 would be the lower limit, it's the smaller value, so our lower limits would be 40, 50, 60, 70, 80, and 90, and our upper limits would be the top sides. That would be 49, 59, 69, and so on, which makes our width, the gap between lower limits, the gap between upper limits, consistently that value of 10 as we designed. Where I want to mention here that with this example, as much as I find this book frustrating from time to time, this is actually the only one of the three I've used to teach this material that thinks to group data in sensible ways that fit the set, rather than some arbitrary choice in terms of the number of classes. They're right on this one. But once we have a table like this, it's better than a clump. It's still a lot of numbers. And even well-organized numbers don't have the charisma of a nice picture. So the next couple of things we're going to talk about here are the ways to represent our data in terms of other sorts of graphs and presentations, starting with what we call histograms and frequency polygons.